In this experiment, communication with Class 1 and Class 2 energy-neutral devices using backscattering is studied. The measurements are performed within the tactile testbed. This wooden room inside a room emulates real-world scenarios and consists of 140 modular tiles at the ceiling, floor and 2 side walls. Each tile consists out of 2 antennas and a software-defined radio to transmit or receive RF signals, a Raspberry Pi form to perform local processing, and a Power over Ethernet module to deliver power from and communicate with a central server. The testbed is time and frequency synchronized, given that multiple software-defined radios would generate exactly the same frequency from a shared 10 MHz clock source. Our objective is to achieve uplink backscatter communication with an energy-neutral device. Carrier suppression by static backscattering is chosen as this overcomes the self-interference. This requires 3 components in the measurement setup. First of all, we need a carrier generator. A radio signal should exist at the energy-neutral device that can be backscattered. Depending on the conducted measurement, this radio signal with a frequency of Fc is generated by either a signal transmitter or by multiple transmitters. The second component is the backscatter device itself. The incoming radio signal is either absorbed or reflected, depending on the data signal. To suppress the carrier signal, a local oscillating signal at FLO is switched on or off at the data rate FD. As backscattering in all its essence is a mixing process, the carrier, oscillator and data signal can be easily observed in the spectrum. The last component is the signal demodulator. Both the carrier wave and the backscatter signal are received by an allocated receiver, which in its turn demodulates this signal to retrieve the necessary data. The tactile infrastructure allows for power spot generation at the energy-neutral devices with techniques as described in the REINDEER experiment 4A. In this measurement setup, 42 ceiling tiles are used to generate such a spot. The in-house developed energy-neutral device consists of a low-power microcontroller and an RF switch. It is the microcontroller that generates both the local oscillator frequency at 512 kHz and the data signal. At the energy-neutral device, the power spot is reflected back and received by the side panels in tactile. On-off keying demodulation is performed by down-converting and filtering the received QI samples, finding the start of each packet by means of cross-correlation, and getting the binary data by adaptive thresholding and resampling. Bit error rate testing shows that this non-coherent on-off keying demodulation technique is very susceptible to errors in the sample and data transmission rate, and that there is clock wandering due to the microcontroller local oscillator. Timing error detectors such as Early Late and Gardner could potentially recover the clock and improve symbol synchronization, lowering the bit error rate drastically.